Alright, hello. Today in this video, I'm going to walk through this first order transient analysis problem. I got this problem from Circuit Tutor. I'm making this video because whenever I took this class, first order and second order transient problems were kind of difficult for me. So I'm hoping this will help you with that. Alright, so first off, we'll see that this is a first order circuit because we only have one inductor or one capacitor. In this problem, we have an inductor. And in first order circuit problems, we know that the solution is going to be something like this. K1 plus K2 equals negative T divided by tau. Okay, now the next step is we want to analyze for T equals minus, 0 minus. And then we want to solve for the inductor current. If this is a capacitor, we would want to solve for the voltage. Or you can solve for both, but generally only one is going to be really useful in the long term. Okay, and whenever we're in T equals 0 minus, we're assuming that the circuit has been there forever, so the circuit is in steady state. And for an inductor, the steady state is a short circuit. So we'll go up to the inductor and put this right here to make it a short circuit. And then this is the switch will be closed as well, because it opens when T equals 0, and we're before that. So if we look here, this resistor right here is now shorted because this is closed and this is closed. And then, so now we want to solve for the inductor current, and since this is shorted, this will be open. So here, let me put this. IL. If this is now open, or not necessarily open, but it's gone because it's shorted, you can see that there will be no current going through this now, right? Because it's hanging. This is gone because it's shorted, so the current through the inductor will be 0. Let me bring everything back. All right. So the inductor current IL for 0 minus is 0 amps. Okay. Now the next step is to analyze for T equals 0 plus. So right whenever the switch closes, and we want to solve for the sought value, which in this case is this I naught, which it says in the problem statement. And remember that the inductor current at T equals 0 minus is the same as 0 plus. So we will go up here, and since the inductor current is 0, that is the same thing as an open circuit. 0 current is the same thing as an open circuit. So we want to close this, or actually open this now because we're at T equals 0. And now this will be open up here. This inductor will be open. And since this whole resistor right here is hanging now, and this voltage source is hanging, so these basically aren't doing anything to the circuit. So that just leaves us with this one loop right here, right? Because these are both hanging, this is hanging. We only have this loop right here. And since there's no source here at all, we just have this single loop with two resistors. We can already just know that the I naught is going to be 0 amps because there's no source to actually give any current or voltage. So we know that I naught of 0 plus, or just 0 in general because it doesn't really matter for the saw value, is going to be 0 amps. Okay, now we want to analyze for T equals 0 infinity. So now it's basically steady state but with the switch open. So as we said before, in steady state for an inductor, we have a short circuit. This switch will now be open. So this leaves us with this circuit. And you can see that this will just be a two-loop or two meshes that we have to solve for. So we're just going to do mesh analysis, call this I1, call this I2, and then write our equations. So we know that for I1, we have for the right here, 9I1 minus I2 plus 6I1 equals 0. And then for I2, the second mesh, we have 9i2 minus i1 plus 3i2, and then we have this voltage source, so minus 8 equals 0. Then we also know that this current through loop for I1 is the same as I naught of t. So I1 is equal to I naught. Okay, now we just break down the equation. So for this equation here, you just distribute it. Okay, I1, 9i2 plus 6i1 equals 0. And that gives you 15i1 minus 9i2 equals 0. Okay, the second one, this one over here, we have 9i2 minus 9i1 is 3i2 equals 8. We do some more simplification. Okay. Alright. Now if you just plug this into your calculator, if you have a TI, there's like an app where you just plug in the numbers, or you can just use a matrix. It should get I1 equals 0.7273 amps, and I2 equals 40 over 33 amps. And as I said before, I1 equals I naught, so I naught equals 0.7273 amps. Okay, on to the next step. So the next step, we want to find the Thevenin resistance viewed from the inductor. So when we want it viewed from the inductor, we want to view it from the terminals of the inductor. So we make that open, and then whenever we're finding Thevenin's resistance, we get rid of all the sources, so this will be a short circuit in the case for the voltage source. Alright, now we just do resistor combination. We can see that this 9 ohm resistor and the 6 ohm resistor are in parallel, and these two in parallel are in series with this 3 ohm resistor. So we can just write that out. The 9 ohm is in parallel with the 6 ohm, which is in series with the 3. Then I do the parallel like this. So that will give us R Thevenin equals 6.6 ohms. Right, that was pretty easy. Right, now we just solve. So, as we said in the very first step, right over here, we know that our solution is going to be in this form. So we know it's going to be K1 plus K2 times e to the negative t over tau. Okay, but we don't know what tau is yet, so we have to find that first. And over here I have it written for an RL circuit, which is what we have, tau equals L over RTH. So tau equals L, which in our case, I think it's, I have it gone, but it's 5 henries. 5 henries over R Thevenin, which we found to be 6.6 ohms, which will be 0.758. This is in seconds. Okay, now we have to use our initial conditions that we found. So we know that I naught of 0 is 0 amps, and we know that I naught of infinity is 0.7273 amps. So we use these initial conditions to solve the equation. So we know that when I naught of 0 equals 0. So 0 equals K1 plus K2 e to the negative 0 over tau. Or in other words, 0 equals K1 plus K2. And we know that 0.7273 amps equals K1 plus K2 e to the negative infinity divided by tau. And this right here, e to the negative infinity, this will become 0. So that is 0. So we know that K1 equals 0.7273 amps, and we can put that into that equation. So we get 0 equals 0.7273 amps plus K2. So we know that K2 equals negative 0.7273 amps. And now we know what both K2 and K1 is, and we know what tau is, so we just plug them into the equation. So we get 0.7273 amps minus 0.7273, because we don't really need to put the amps right there yet, e to the negative t over tau, 0.788. And that's going to be equal to I naught of t for I naught for t greater than 0. And this is our answer for this problem. I hope this was helpful, and yeah.